Welcome back to another exciting episode of Do Your Math. Today is reteaching 15-6. This shouldn't take very long, but it is pretty cool, so pay attention. You will need a ruler or some type of straight edge, a pencil, a pair of scissors. Okay. So in your week 4 packet, there are several pieces of graph paper. So please get one of these pieces of graph paper for reteaching 15-6. So we're going to go through 15-6 proper and to go through the mathematical reasoning, and I'll explain a little more as we work through this. So come along. Hopefully it is not raining today. Were you going to stay in the house and get in trouble like the Cat in the Hat? All right, so if you look at 15-6, it says, here is a generalization to be tested, and you are going to test this on the graph paper. So if you notice, they have drawn out a square, which means there are 4 equal sides, and you're going to do this on the graph paper in just a moment. And they've labeled each of the vertexes. Remember, vertexes where 2 line segments meet. Then they have drawn a diagonal, and you're going to cut this out, and when you cut on the diagonal, this is now called the hypotenuse. I just want you to be aware of that terminology, not that you'll be tested on that. But so if you look at this, when we cut this square out, which means since this is a square, these are right angles. And this is really important that you understand this. So now we have like so. Now, mathematically, these are the same measurements, because if you were to rotate this, A and C, let's see, A and C, they have put these, why did they do this? Okay, I don't want to go A and C, but A and D would equal B and C, the lengths here. D and C would equal A and B. So let's go down to the explanation. It says show that triangle ABC and CDA are the same size. Well, I kind of tipped my hand to that one, because we can say that line segment BC is equal to line segment AD in the triangle. We could also say that DC is equal to AB. Again, these are line segments. So that's pretty much, it for the reteaching. Now, I do want to go on to, you're going to test this generalization with the graph paper. So what you're going to do is you're going to take this graph paper, and I do want you to take your time. Don't give me the, I'm just kind of drawing really bad lines on top of the grid. So I want you to make 2 squares and 2 rectangles, and you should have more than enough space. Don't make them huge. But let's just go, let's make 1 square, 1, 2, 3, 4, 5, 6. So we're going to make it 6 by 6. So remember, a square has equal sides. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So right there. All right, so I'm going to come across. One, 2, 3, 4, 5. 3, 4, 5, 6. I'm going to go back. I'm going to go ahead and I can make it a little easier to see. So I'm just going to complete the other sides neatly. So remember, you don't need a ruler. All you need is a straight edge. All right, so I have a 6 by 6 square, 6 units by 6 units. Now I'm going to draw the diagonal. Make sure you get it into the corner, the vertex. Okay, voila. I'm going to take my pair of scissors. I'm going to carefully cut this out. Please don't cut your fingers. Don't cut your fingers off. I want you to come back with 5 fingers on both hands. So I'm going to very gently cut, and I'm going to try and keep it right on top of that line as best as I can. Because the really cool thing about this is when you cut along that diagonal, you're going to find a really interesting generalization. So I'm going to take my 2 triangles and I'm going to overlap them. And they should be identical. Now, what I want you to do is I want you to write down what type of triangle this is. When you cut a square along the diagonal. So think about it. You have a square, you cut it along the diagonal. What kind of triangle does that become? So do that a couple times. I'm only going to do one, and I'm going to do another one. And I think this is a rather interesting generalization. If anybody can prove it wrong, guess what? You're going to win the Nobel in mathematics. Okay, so what you're going to do, I don't care what the dimensions are, but I want you to come up with 2 dimensions, length and width, for a rectangle. So, and they do have to be 2 different ones. You're not drawing another square. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So, and then I'm going to go 6. So 1, 2, 3, 4, 5, 6. And I'm going to double check myself. 1, 2, 3, 4, 5, 6. I'm going to come back up. And 1, 2, 3, 4, 5, 6. And then I'm going to finish this off. Remember, this rectangle has to be a 4-sided closed plane figure. And just like with the square, I'm going to draw a diagonal into opposite vertices, like that. So again, same process. I'm going to cut this out. Remember, I want you coming back to school with 5 fingers. Don't drop it, because we want you to come back with 5 toes as well. Don't drop it being the scissors. So I'm going to go back and I'm going to trim this off a little more neatly. So again, I'm trying to stay right on top of that line. And so you're going to cut that on the diagonal here in just a moment. And, since you're just doing a few squares and rectangles, you can make these a little bit larger than the ones that I'm showing you right now. But, again, remember, the way you disprove a generalization is come up with one, and it only takes one example that doesn't fit the generalization, and you win the Nobel in math. Now, you have a rectangle You've cut along the diagonal, rotate it, and see what happens. So, what type of triangle have you produced from a rectangle? So I want you to write that on your reteach side. So what type of triangle is made when a rectangle is cut along its diagonal. So don't forget to put your answers on the reteach side, and good luck with the 15-6 practice. See you later.